Good afternoon to all. My name is Ergo Pikas. I'm happy to say that I have two other colleagues and the co-authors of the papers here in the room, Elisa, Iliste, and Tanya, Bloch. And today, the work that I'm presenting actually stems from the personal motivation and maybe some egoistic reasons, because I have had some struggles of having students to do proper digitalization and construction informatics research, so I decided that we probably need some kind of a program. But establishing a study program, I'm sure it's the same in other countries as well, it's not actually easy. You need to convince a lot of people internally, but you also eventually need to get approval from the ministry. So I started having a few years ago lunches and breakfast with some of the most important people to kind of give hunch that we are having some kind of plans to develop such a program. And eventually when I presented the draft program, they were, oh, this is excellent, we're going to do it. So they were prepared to see the program itself. So quick introduction, I'm not sticking on those slides for too long. The integration of the computation into AEC started around 1960s. We know Chuck Eastman, one of the originators of the field. But what we have also recognized in the industry is that realizing the full benefits of the digitalization and construction informatics requires actually the domain understanding. But when we look into the existing study programs or the literature, what is out there, the focus tends to be on the design and building information modeling aspects. So this was the kind of the starting point for this research, and we wanted to see what is out there existing, what are the other universities doing in order to actually establish our own program and have argumentation or justification why we actually need it. Yes. So you all know about the industry needs, the challenges we are facing, from complexity to productivity, sustainability and collaboration. I personally have been putting a lot of emphasis or effort in the last few years on the sustainability and collaboration topics, got in together with the digitalization approaches. It's not working very well. And we still see some limitations or the challenges we are facing in the industry. They are still pertaining. We have fragmented processes, skill gaps, training opportunities, but we are lacking process redesign. So in terms of the research background, what we focused or what we discovered is that there are three generic most important concepts for the development of this new program. First of all, of course, we want to teach the computational thinking, which is the problem-solving methodology involving decomposition, abstraction, algorithmic design, iteration, and generalization. But we want to do it together with the domain engineering. That is basically understanding the fundamentals and the processes of the design and construction processes, and starting from there. So in order to actually utilize the full benefits of ICT, as we know, Bill Gates said it 10 years ago, that if we optimize or digitalize the chaos, we get a digitalized chaos. So start from the processes themselves, redesign the processes, and then implement the digital technologies. And of course, what can inform us, we have seen here Professor Raffel-Sachs presenting digital twins in the construction sites. So the production management for design and construction is something that can inform us in developing those things. So that is what we're arguing here, that it's not just enough to teach computation or construction informatics, but we need to find a balance between the construction informatics and the domain understanding and knowledge. So there is a field called domain engineering, which we know often as a design of the, or the domain analysis, design of the domain aspects, such as data modeling, data management processes, and etc. for the construction. And then from there, we actually need to focus on the development of the requirements for the software products we are having in construction industry, and then develop those solutions and then test and implement them as well. So you need to have the interdisciplinary focus, domain-centered ICT approach, experiential learning. This is something we have been trying to develop at our university. So we have different teaching styles or educational styles, like design-based education, project-based education, and what we are trying to do in our study program level to balance those different approaches. Not just only teach the problem-based or the project-based approaches, because all of these have different benefits and also challenges. And of course, it requires continuous learning, upskilling, also the faculty members and partners of the project. So for this research, to understand what is out there, we defined the aim to frame the development of the new study program. For that, we identified or defined 3 different research objectives: to identify current landscape of digital construction programs, uncover patterns and gaps in program content, reinterpret limitations and opportunities to reframe our program. Overall, the research was divided into 2 steps. First of all, exploring the internet to find similar existing programs out there. We selected 15. Of course, there are a lot more, but we just wanted to be representative in the sense of having programs from different locations and from universities where we know that there is a strong digital construction approaches and research happening. And then from there, we went on to do a detailed analysis of the 5 existing study programs. So this is just a quick overview. I'm not going into the details. You can see that these are from the different continents, and they have different backgrounds in architecture, architecture engineering, construction management, structural engineering, even a few programs or some programs on geosciences and things like that. And what we discovered is that, of course, the strong emphasis or the focus seems to be on the BIM and simulation approaches or technologies. There is some moderate coverage. I guess it depends also on the selected number of selected programs and what kind of programs were selected. We see some focus on the AI, ML, digital architecture and programming, limited attention to robotics and printing, 3D printing. So for limited focus on the physical processes of construction production. So overall, the finding is that architecture programs tend to focus on virtual aspects, and while engineering programs tend to focus on the BIM and data management. So these are the 5 selected programs for the more detailed analysis. You see here a list of programs from different universities in different locations, such as, for example, TUM from the Technical University of Munich. So it's a very fascinating, very interesting program. It's a master's program, accepting students from the different backgrounds, including architecture, civil engineering, and even geodesy and IT or computer sciences. And their focus is on the development of the skills and competencies for the engineering of software products or systems. And this is what they have stated. This is their main aim and the focus of this program. So they cover courses such as geospatial information sciences, computation design and architecture, photogrammetry and remote sensing, and of course, quite a few courses on computer sciences, programming, database management, and etc. So the main findings from the studying those 5 programs in detail, I would say that different programs, because of their different focus, have different challenges, but also different limitations. That makes sense, because we need to select some kind of focus. Yes. So for example, we have the DUM that I was just mentioning. The focus tends to be on the interdisciplinary digital technology in AAC. Strengths include broad overview, project management topics, and etc., but limited focus, for example, on the construction management and production management aspects. So for the discussion, so what we see, if you take digital twin kind of view of the world, where we have the virtual space and the physical space, the focus, of course, tends to be on the digital and BIM-related aspects. And there is limited attention on the construction processes and management of productive assets. And also a bit of insufficient coverage of the built asset maintenance, which makes sense. What are the contributing factors? These are not actually new. We see them in many different places, also in BIM education, for example, where I have published quite a few papers as well. So limited faculty expertise, implementation costs, especially for example, 3D robotics, printers, robotics, things like that. Insufficient coverage of construction management and segmentation subject areas. So there is lack of interdisciplinary approaches of delivering those programs. So the underlying concept for the development of the program, what we decided is then that we need to focus on the fundamentals, give very strong fundamentals in terms of computational aspects, AEC, ICT technologies, construction, production, and management concepts, and then have specialization in terms of the advanced digital technologies, but these need to be integrated into actual design and construction processes. So for the development of the program, we decided that the progressive upskilling, domain-centric ICT engineering, physical, digital, human integration, and the continuous improvement should be the underlying principles for the development of this program. So this is, in the paper we don't actually cover the design and the development of the study program, but based on the construction management program at the Daltech or Tallinn University of Technology, I did a review what is already on the program, what can be left out, because the program is already quite full, so not everything can be taught. And this was divided into 2 modules, so we have traditional construction engineering and management courses, and then we have a new module which is directly related to the digital construction and construction informatics topics. And here what we did, we divided, based on the disciplinary approach, the topics into 4 different categories. This is the common to all these different 4 specializations that we have in mind, but we have specializations to get the data capture, directly capture technologies. We have specialization, for example, for the data analysis, modeling, simulation. But here on this last track on the construction and production and industrial processes, so for example, we have new courses such as AI in industrial engineering companies or etc. And that's so what I missed to show that something missing. Okay, so the program, this new part, is developed by combining existing study programs. So we actually try to avoid as much as possible of developing new courses, because it's forbidden basically now in university to say it's already full, so we have to rely on existing things. So we combine basically with the construction management program from our faculty, and then the business information system from the IT faculty, and then finally industrial robotics from the industrial engineering faculty. And with that, I would like to finish. Thank you.